Hi students, good evening to all of you. Today we are going to discuss about molecular orbital theory part 3. Okay, here we are going to discuss about how to find bond order of resonance structures. Let's start here. One formula I am giving to you, just follow it. That is, bond order of resonance structures is equal to total number of covalent bonds, that is between carbon upon number of resonance structures. Right. For example, benzene, C6H6, molecular formula, then structural formula. Right. Here in benzene, between this carbon and carbon, how many bonds are there? Carbon bonds here. Here this carbon having how many bonds? This carbon having this side one bond and this side one bond and this 5 bond. This is third bond, right? So that means this particular carbon atom having 3 bonds. 1, 2, 3. 1, 2, 3. So that's why each carbon having 3 bonds, carbon. I am not saying about carbon hydrogen bonds. Okay. So that is the number of covalent bonds is 3 and number of resonance structures. Benzene can form 2 resonance structures. That is 3 by 2. Right. Then for example, how much you get? So 2 ones 2 and that is 10. Then 2 5s 1.5. Right. Okay. Next, for another example, ozone molecule. Right. For ozone molecule, you have to draw the structural formula. 3 oxygen atoms between 1 and 2 oxygen atoms double bond and 2 and 3 oxygen atoms coordinate bond is present, single bond. Right. Now, here the total number of covalent bonds of that particular oxygen. So this central oxygen having 1, 2, 3. 1, 2, 3. That's why total number of covalent bonds of oxygen is 3. Ozone can form 2 resonance structures. Right. That is 3 by 2. It is also 1.5. Right. Okay. So this is the bond order for ozone and also benzene. Got it. Next one. For some structures, for example, carbonate ion, sulfate ion, phosphate ion, perchlorate ion. How to find out for this? Instead of this formula, one simple another quick formula is there. You just follow this one. That is, the bond order is equal to group number value, that is Roman number, okay, group number value of central atom. That central atom belongs to which group in the periodic table? That is Roman numerals upon number of oxygen atoms. That are surrounded by the central atom. Right? You just follow this trick, my dear students. By using this trick, we can solve some examples. See, for example, if you take carbon dioxide central atom, carbon, it belongs to 4th A group, Roman numerals 4. Arabic numerals 14th group. But Roman numerals 4th A group, 4. Number of oxygen atoms, how many here? 2. Right. So 4 by 2, 2. There is a bond order of carbon dioxide. Next, second example. Take carbonate ion CO3 2 minus carbonate ion, right? This carbonate ion, what is the bond order of carbon here? Carbon belongs to group number 4. How many oxygen atoms? 3, right? So 4 by 3, how much you get? That is 1.33 you get, right? Next one, another example. Take silicate ion, SiO4 4 minus silicon, central atom. Silicon also belongs to which group? 4th group. Then how many oxygen atoms are surrounded? 4. That is 4 by 4, 1. That is the bond order. Next, another example. Take a 15th group, phosphate ion. It is previous year question. PO4 3 minus phosphate ion. So phosphorus belongs to 50th group, Roman, that is Roman numerals 5, group number 5. Upon oxygen atoms, how many? That is 4 oxygen atoms are there. 4. Then 5 by 4, how much you get? So 4 ones, then 4 twos, then 4 fives. 1.25, right? Next, for sulfate ion, 16th group, 6th group, right? SO4 2 minus. So here central atom, sulfur. So sulfur belongs to which group? 6th group, Roman numerals 6. How many atoms are? 4. 6 by 4. How much you get? 1.5. Right. Next, for perchlorate ion. Formula ClO4 minus perchlorate ion. Right. Here chlorine belongs to which group? 7th group. So group number value 7. Oxygen atoms how many? 4. Then how much you get? 1.75. Right. Okay. Now here, these are all different resonance structures. You have to know the resonance structure. Then only you find out the bond order value. But by using this trick, it is very easy to find out, right? So this is perchlorate ion. It is appear. It is a previous year examination question, PYQ. And it is a phosphate ion also. And a CO2 also, right? Okay, fine now. Next one. So got it here. So this is the method you have to follow it. It is 2, it is 1.33, 1, it is 1.25, 1.5, 1.75. Next one. Another one. So here, these are the bond order for different resonance structures. But some cases, for example, perchlorate ion is there. That is ClO4 minus. Next, ClO3 minus. ClO2 minus. So here, all the central atom belongs to same. That is 17th group. But oxygen atoms are different. In such a case, here central atom is different. Okay, oxygen atoms are different than this formula. If central atom is same and oxygen, that is bond atom is also same. Okay, if central atom is same, then to find out bond order, one more trick formula is there that you have to apply here. So bond order is equal to here the oxygen valency of oxygen, my dear students, valency of oxygen plus valency of oxygen. I am not saying about valence electrons of oxygen. Valency of oxygen plus charge on the ion. Charge on the ion upon number of surrounding atoms. Number of surrounding atoms or oxygen atoms. Right. Here, this formula you have to apply for finding bond order for perchlorate ion, chloride ion, and hypochlorite ion. Right. So how to find out here? So see, one example I will give to you. You have to write valency of oxygen. Generally, students are immediately they are saying 6. No, that is valence electrons. I am saying about valency of oxygen is 2. That is 2. Then charge on the ion 1. Charge on the ion, that is minus 1 you have to apply. Charge on the ion, it may be plus 1 or minus 1, that is minus 1. You have to apply minus 1. Number of surrounding atoms 4. Okay. So this is the value you have to get it. Then how much you get it? That is only the bond order value. You will get it here. This is 1.75. And for this ClO3 minus. For ClO3 minus what you have to apply? That is valency of oxygen. That is 2 plus charge minus 1. Then that is surrounding atoms of 3. Then you will get it. The value, how much you will get it here? It is 1.67 you will get. 1.67. And for this one, that is valence of oxygen is 2. And charge is minus 1. And surrounding atoms 2. Then you will get it is 1.5. Got it? So these are the formulas you have to use to find out bond order of resonance structures. Okay, right. Next one. One more thing here, magnetic property. It is also important. How to find out magnetic property, my dear students? One simple trick. Okay, here one simple trick, my dear students. What that is here? Magnetic property, you have to find by simple trick, that is, if the total number of electrons of a molecule or a ion is odd number value, okay, total number of electrons of a molecule or a ion, if you are getting the total number of electrons is odd number value, okay, it is a odd number value, then it is a odd number value, then that is odd number of electrons is there, right? You know, magnetic property, the given molecule or ion, it is a para or dia. How can you say is, if minimum one unpaired electron is present, that is para. If there is no electrons, that is electrons are empty, or there is no unpaired electrons. I am saying about no unpaired electrons, that is dia. If minimum one unpaired electron is there, that is para. If odd number of electrons means unpaired electron is there, so that's why this is a para. But if the total number of electrons of a molecule are getting even number of electrons, then that is dia. That is dia. Even number of electrons. Even number means you are getting paired, right? Pairing means no unpaired electron, right? No unpaired. But here one exception is there. That is for O2 and B2, for oxygen and for that is beryllium and that is boron B2, right? So you will get here, this is 10 electrons you will get, and then here oxygen 16 electrons you will get. So you can think it up, sorry, even number is there, 8 pairs here, 5 pairs. So that's why it is dia. But in this case, in the case of O2 and B2, it is not dia, it is a para. Why? Because if you write electronic configuration, MOT3, according to MOT3 electronic configuration, therefore O2 will get the last 2 electrons enter into, that is after 14 up to N2, next last 2 electrons enter into anti-bonding, that is pi orbitals, that is star pi 2px1 and star pi 2py1. So 2 unpaired electrons will get. So that's why these two are para. That is the paramagnetic property of oxygen molecule is explained in terms of Vesper theory, no molecular orbital theory. Got my point, my dear students? Yeah. So now I explained for resonance structures, 3 formulas I gave. Just keep in your mind. You just keep this formula in your mind, then you can easily do it. Keep right. And the magnetic property also I gave the simple trick for any molecular ion. You just follow this one. It is very easy to get it answer, right? Okay. So thanks for watching my video, my dear students. If you like it, then subscribe it and share to your friends. Fine, ma'am.